Hello, my name is Corey McCall, and in today's presentation, we're going to discuss conducting a correlation analysis. First on the agenda, we're going to review what a correlation analysis is, and then we're going to discuss 6 variables, one being income and debt, then income and savings, then income and stocks, savings and stocks, debt and stocks, then number of credit cards and savings. Thereafter, we're going to discuss some takeaways, and then we're going to open it up to questions. In reviewing a correlation analysis, in order to determine a relationship between two variables, a correlation analysis must be performed. A correlation analysis is a statistical method of an evaluation used to determine the strength of a relationship between two numerically measured variables. Examples are age and height. A researcher may use this information to determine if there is a correlation between the two variables. Using both significance and p-value, a correlation analysis will determine whether a hypothesis is confirmed, sustained, or not as a result of a correlation test. In our first example, we're going to take a look at income and debt. So we're going to first take a look at a null hypothesis saying there is no correlation between income and debt, and then an alternative hypothesis saying there is a relationship or correlation between income and debt. Of course, in looking at this information, PSPP, which is a tool used to perform and conduct a correlation analysis, a two-tailed one, we're actually looking at the alpha remaining constant at 0.05, and we have a significant correlation coefficient of negative 0.05 and a p-value of 0.535. As a result of the test, the null hypothesis is rejected, and there is a relationship between self-supported income and debt of a USD participant. In our second example, we're looking at income and savings. The null hypothesis states there is no relationship between income and savings. The alternative hypothesis states there is a relationship between income and savings. We have a correlation coefficient of 0.91 and a p-value equal to 0. As a result of the test, the null hypothesis was rejected, confirming a relationship between self-supported income and savings of a USD participant. In our third example, we're looking at income and stocks. The null hypothesis states there is no relationship between income and stocks, and the alternative hypothesis states there is a relationship between income and stocks. We have a correlation coefficient of 0.19 and a p-value of 0.018. As a result of the test, the null hypothesis is rejected, and there is a slight relationship, there's a weak relationship between self-supported income and stocks of a USD participant. In another example, we're looking at savings and stocks. The null hypothesis states there is no relationship between savings and stocks. The alternative hypothesis states there is a relationship between savings and stocks. The correlation coefficient is at 0.28, and the p-value is equal to 0. As a result of the test, the null hypothesis is rejected, and there is, again, a weak relationship between stocks and savings of a USD participant. Another example, we're looking at debt and stocks. The null hypothesis states there is no relationship between debt and stocks, but the alternative hypothesis states there is a relationship between debt in stocks. The correlation coefficient is equal to negative 0.05, and the p-value is equal to 0.555. As a result of the test, the null hypothesis is rejected, and there is a relationship between debt and stocks of a USD participant. Now, last one, we're looking at a number of credit cards in savings. The null hypothesis states there is no correlation between the number of credit cards and savings. And the alternative hypothesis states there is a relationship between the number of credit cards and savings. Correlation coefficient is negative 0.5. P-value is 0.50. As a result of the test, the null hypothesis is rejected, and there is a relationship between the number of credit cards and savings of a USD participant. So some takeaways here are, in order for a null hypothesis to be accepted, it is dependent upon the value of the correlation coefficient and p-value. The PSPP tool provides a two-tailed correlation analysis, and this is activity. And alpha is used to be a constant of 0.05, and a correlation coefficient is shown to indicate how close or far away a hypothesis is from being accepted, along with its p-value. Thank you for your time. I'm opening it up to questions. If you have any, please let me know. Thank you.